Okay, this is topic 19.6. We're going to do a little bit more function applications with area and volume, mainly area today. So let's look at example 1. It says a rectangle has a perimeter of 100 feet and has sides x and y. Express the area of the rectangle as a function of x. So we are going to express the area of a rectangle. Remember, area is length times width. We're going to write the area as a function of x. So that means instead of L and W, L and W in the formula, we want to make it in terms of x. So let's draw a picture over here for what we're talking about. So we have this rectangle, and we know the perimeter is 100. And we know the sides are x and y. Okay, so we want to make the length in terms of x and the width in terms of x. Well, our width is already in terms of x, so let's take the perimeter formula for a rectangle and let's plug in 100 for the perimeter and y for the length and, and x for the width. Now what I want to do is I want to solve this for y so that I can change the y to an expression in terms of x. So I'm going to subtract 2x to the other side and then divide by 2. And I'm going to divide both of those numbers or both of those terms by 2, and so I get y equals 50 minus x. Okay, so now I have my width as x and I have my length as 50 minus x. So I'm going to come back over here to my area formula and I'm going to replace L with 50 minus x and I'm going to replace the width with x. And that would be my area formula as a function of x. So now B says find the area of the rectangle when x equals 20 feet. So all we're going to do then is plug in 20 into our function. And so we'll have 50 minus 20, which is 30. And 30 times 20 will give us 600. So the area when the width is 20 is 600 feet squared. And that's just a little bit of function applications, making an equation in terms of x or as a function of x. All right, let's look at another problem. This says an open box is to be made from a square piece of material 12 inches on a side by cutting equal squares of length x from each corner and turning up the sides. Let's sketch a graph, not a graph. Let's sketch a picture of the problem situation. Okay. All right. So we have this box that's going to be a square piece of material. And we know that it is 12 inches on each side. So the entire side is 12. But I want to cut equal squares of length x from each corner. So in this corner, I'm going to have a square with length of x on each side. And I'm going to do that in every corner of this box. So what's going to happen is when I fold it up then, now the length from here to here will be 12 minus 2x. Because this is length x and this is length x and the whole thing was 12. And on this side, from here to here is 12 minus 2x. So we want to express the volume as a function of x. So we know that volume of a box or a prism is length times width times height. Rectangular prism is length times width times height. So as a function of x, then the length of that box is going to be 12 minus 2x. The width of the box will be 12 minus 2x, and the height of the box, we're going to fold these corners up, so the height of the box would just be x. And you don't have to multiply all that out. You can just leave your equation or your function written like that in terms of x. Or I guess we could simplify it to this. You could write it as 12 minus 2x squared times x. All right, so it says find the volume when x equals 4 inches. So all we're going to do is we're going to plug in 4 into our function. So we're going to do 12 minus 2 times 4 squared, and then times 4. So 12 minus 8 gives us 4 squared times 4, and that gives us 64. And we're working in inches, so this would be 64 inches cubed. Okay, and those are just some examples with area and volume of rectangular prisms.